The next control flow we're going to talk about is the for loop. Now, with a for loop, it actually iterates across a sequence of particular things, whether it's a list, string, tuple, or what. So here's a quick example. So we can use a for loop to step through, quote unquote, or read through this list. A for loop can iterate through it. So the basic structure for a for loop is we can do for and then I in X, and then we'll say print I. Now we're in idle, we don't need print, but just to show you that it goes through the list, it steps through the list one at a time, and because it's a list, it can contain everything from float values to integers to strings, and it goes through it or steps through it, and it takes each item as it is. And an interesting fact is if we don't want to list everything top to bottom, we can also do this. For I and X, instead of print, just saying print I, we can say end equals, and then this does something that's nice. It gives us a cross list of this. Now, other things we can do with a for loop, we can say, so we can do for I in range 100. So we can do for I in range 100, and we can say print I end equals an empty quotes, and then we can see that it actually prints from 0 to 99. Now, if we want from 1 to 100, the range command is built such that it has its default values, but if we want to be specific, we can tell it to start at 1, end at 100 with a step of 1. And then we'll say print I end equals, and that gives us our 1 to 100. Now we can also use the for loop for continual calculation. So we can do this, and we can say print I divided by 2, and that is 1 divided by 2, and so on and so forth. 2 divided by 2, 3 divided by 2, 4 divided by 2, all the way to 50, because this last portion would be 100 divided by 2. So this gives us the ability to do mass calculations. Okay, this next for loop example employs the, I'm going to say, package or import module import random. So in this case, we'll say X is equal to the list 3, 4, 1, 23, 8, and then we can say random, instead of saying random.ran range, we can use the random method choice, in which it selects a random choice from whichever data store we have. In this case, it's X, and it selects 8, and here it selects 8 again, it selects 4, and it selects 23. So we can exit this, and we can take a look at this program glist. It's actually grocery list, and we can press enter, and it says, Hun, I bought milk, and then the reaction is wrong size. Hun, I bought eggs, reaction is did you even look? Hun, I bought butter, reaction did you even look? Hun, I bought root beer, reaction wrong size. So let's see what is going on with this poor unfortunate spouse, and we can stream the file. So we use the import random module, and here is the grocery list: milk, eggs, butter, and root beer. Now the reaction I gave this person, the spouse, plenty of opportunities. We have great, wrong size, wrong brand, and did you even look? So actually the three of the four comments were probably in the negative, but the way this works is we have a for loop here, for G in glist, and then we say print Hun, I bought a, and then it goes through each of those items in the list one by one, and then we have the reaction, and then we have random.choice reaction. So we can do this again. Hun, I bought milk, reaction, did you even look? And then eggs, see how milk, eggs, and butter follow the list one by one, and then it just is paired or concatenated with the reaction, which is did you even look, wrong brand. Again, these are randomized choices from this collection, and in this case it just happens to be a list, but it is a random choice from this collection right here. So we can even run it again, and oh, look at this, he was pretty good today. He bought the milk, reaction great. Eggs, reaction great. Butter, reaction great. root beer, wrong brand. So that's yet another example of a for loop in action. Okay, in one last example, we're using a for loop and an if-then statement with each other. So the for loop has an if-else or if-then statement nested within it. So the first thing, we go back to that even-odd function. You can take a look at it in a prior video. We then have our doc string right here, and we still are using the module to determine even or odd, but now we have established two lists, an even list, an empty list, and an odd empty list. And then we're saying for my number in range 1 to 100, so it starts at 1 and it goes to 100. This actually should be 101. Let me fix that. And the instep is 1. And so in other words, if we put, for example, the number 5 here, will count up by 5. If we put a 10, it would count up by 10s. So that should give you an idea of what the instep is. If you follow the logic here, it says for number in range 1 through 100. So it's going to march through 1 through 100 with an instep of 1. And for every number it goes through, for every step, it says if the number modulo 2 is equals 0, in other words, if it's even, it's going to print even, but it's going to append it to the even list. And consequently, if it's odd, it appends it to the odd list. Now, I then use formatted print to print out and show the even list. And quite frankly, I think I don't want to start at 1. Let's start at 2, because 1 divided by 2, for example, won't give us modulo 2, but yet we may not say that it's an odd number. So let's be safe and start at 2. Now this again, this print format even list, you recall the formatted version of print, we don't need to have all these intervening concatenation symbols or commas and close quotes and open quotes. All we need to do is start our quote, end our quote, and in between, when we have a variable number, we just enclose that in curly braces. Hence why the formatted type is probably a little bit better than others. And then of course we do the return thank you for playing evens odds, and then we have this line calls the function, and we actually print the function because we wanted to print the return thank you for playing even and odds. And then we also have printing the doc string, which is here. So, and then we always want to make sure we comment our code, so we could say add a comment here, added even odd list structures, and actually these are empty list structures to be filled every time it detects an even number or odd number. So let's go ahead and write and quit this, and let's run it. And we can see that it does do even Steven and odd, even Steven and odd. And here is the even list, 2, 4, 6, 8. Just, we know what even numbers are. The odd list is 3, 5, 7, 9, 11, 13, and so on and so forth. It does show us the return value right here, and it shows us the printed doc string. Okay, I wanted to show you really quickly, the way I ran the program was accidentally cut off. All you saw was the output. So in Linux, because it has Python already, you type in Python 3 and then the name of the Py program, even or odd, and that is in fact the output of it. However, I wanted to also show you, I wanted to stream the actual file, and I wanted to remind everyone that when you have a multi-line file like this, when you have nested control flows, here we have a nested if-else inside of a for loop. The fact that we start everything, the fact that everything is inside a function, you have to understand that the importance of consistent spacing for your indents for your indentation is very important. So from this end to this end is going to be about 4 spaces or 1 tab. So you have to be consistent consistent. Either you're using spaces all along or you're using the tab button. So this is 4 spaces, that's 4 spaces, that's 4 spaces. Now, the if-else control flow that's nested inside the for loop, that's another 4 spaces in there. And then inside this for loop is, inside this if-then statement, we have more indentation. So that's like 12 spaces. So I want you to be aware of how things are indented. And I know as the programs are going to grow, the tendency to get lost in indentation is very easy. And that's why a lot of people think Python can be a little bit of a pain. I understand, because other languages, they don't use spacing for nesting. They use the open and close curly braces for the whole thing. The person that wrote Python really wanted to make it more readable, so he used indentation as opposed to spacing. So anyways, so for example, this one is still about 4 spaces. That's 4 spaces. That's 4 spaces. Obviously, once you end the block of the function, then everything that is outside the block is its own, I guess you could say is in its own realm. So anyways, just keep this in mind as you type out your Python programs.